Hello, can you hear me?
Yes.
Yes.
Yeah.
Yes. And I have a question. I'm
Yeah,
sorry. Um, you have an assignment out for I think tomorrow, but it's no explanation. Were you gonna put that in today?
yeah,
Okay, thank you.
welcome. So today we're gonna finish the section on probability distribution. I introduced this last time and we did some examples. Now we'll be focusing on expectation today. I thought I closed this. Let me close this. It's blocking my view. Okay. So let's it right here. So this is the where we did an example with the mean, variance, and standard deviation of a probability distribution. Today we'll be focusing on expectation, expected value. After that, then I can now put the classwork. Expected value or expectation. Now, the expected value of a probability distribution simply means the theoretical average. It's theoretical average. So the expected value means of a discrete random variable of a probability distribution is the theoretical average of the variable. Let me put it that way. Yeah. So the formula we use, you can see the formula on the screen. The expected value giving us mean, which is sum of x times the probability of x. So we have this, we have done mean before, but that was for frequency distribution, like I explained in last class on Tuesday. So for this time around, it is for the probability distribution. Now, I will give you an example with two questions. One will be on lottery, and the other one will be on business. So what I mean here is that how we can apply this expected value to calculate the gains for lottery and the gain for business. So let's start with this first one. Lottery. It says here that at Mount Carmel Catholic Church annual bazaar, a lottery at Mount Carmel's Catholic Church annual bazaar offers $1,000 prize, one $500 prize, and $500 prizes. So we have how many prizes here? 7 prizes. One of these, and 5 of these. 1,000 tickets are sold at $3 each. Find the expectation if a person buys 1 ticket and if the winning ticket is returned to the pool after each draw. Now, before we start, I want to tell you this. Suppose that you bought the ticket and you won $1,000. Now, they give you a check of $1,000. But if you look at it, think about it, your actual win is not $1,000. I mean, well, that's your win. Your actual gain is not $1,000 because nobody will give you the $3 that you pay for it back. So that your actual gain should be probably will be $987, even though they give you a check of $1,000. The same thing with $500. Your actual gain should be $497 because you have to subtract that $3 you spent already. For $100, your actual gain is $97. So have that in mind as we proceed. So now there are 1,000 tickets were sold, okay? And you win if your number came out. So that means the probability of winning will be 1 out of 1,000 tickets sold, which should be 0.001. You can double check this with your calculator. I can even show it here. on the screen. Why is my calculator at? I closed it. No, I did not. You want me? I opened it. Yep, right here. This moves. So look at this. 1 divided by 1,000. 0.001. Okay? And that's what I got at that place. Now, for loss, maybe the probability of loss will now become the complement of that. That is 1 minus the probability of win. However, we have how many wins here? This is 1, 2, 3, 1, 2, then $500 bill. So it's gonna be for seven of those wins, for 7 of those possibility of winning. So we have to do 1 minus 0.001 for the first one, which is for the winning $1,000 prize, plus 0.001 for winning $500 prize. Now, this one, there are 5 of them, 5 $100 prizes. So we're going to have 5 of them. Okay. 0.001. Okay. Okay. 0.001 plus the last one, which is 0.001. So now we have 7 of those. 1, 2, 3, 4, 5, 6, 7. Then close it. That will give you the probability of a loss. So let's go and do it on the calculator. Okay. We have 1 minus 0.001 plus 0.001 plus 0.1, okay, plus, okay, 1, 2, 3, 4, 5, 6, 2, 4, 7. One more plus 0.001. Close it. I'm missing something. Give me 1 minute. Let's see what I'm missing there. So now we have 1 minus 0. Okay, plus, okay, 0.001 plus 0. Let me see what is wrong here. Oh, I see it. 0.001 here. So it's 0.9 993. 0.993. 0.993. So the probability that you will lose, I think I'm going to move this to next page so we have enough room. Okay, so you can see how high the probability that you will lose is 99.3% chance that you will lose, and only 0.101% chance that you win. Anyway, so now let's put the wins and the required probability so that we can calculate the expectation. Win, like I said, if you win $1,000, they give you a check, but your actual gain is $997. $997 because nobody will give you your $3. You paid for it already. The same thing applies to 500. It's gonna be $497. Now for $100 bill wins, your actual gain will be 97. Again, for the same reason, nobody will give you the $3 you paid for them. You know, and there are 5 of them. You're gonna go to 5. Then of course you can also lose. Most time you lose anyway. That is $3. So you're gonna make it at -3. Okay. With this, we are ready to calculate the S times PS, but let us put the probabilities. For winning is at 0.001 for all of them. Okay. 0.001 Okay. All right. Now for 3, which is the loss, is you have a probability of 0.993. So now we can now get our x times px, which is this times each of the wins times the probability of that win. So 997 times 0.001 will give us 0.997. 497 times this can give us, you can verify it with your calculator, 0.497. And 97 times 0.001 will give us, let me make sure, 97 times 0.001. 97 times 0.201 give us 0.097. 0.097 for all of them, but with a $100 bill. Okay, 0.297, 0.097, 0.97, 0.097, 0.097. Now this one, which is negative 3 times 0.993. Let me write it down on paper so that I negative 3 times 0.993. Let's go and put this on the calculator. Negative 3 times that. Okay, negative 3 times 0.993. Give me negative equals negative 2.979. Okay, so I'm going to go back and put it. Okay, negative 2.979. Now, we can now calculate our expected value. Expected value means sum of x times px. These are all x times px. Let's add them to get our expected value. So I'm going to write this down so that we can go and put it in the calculator. First one is 0.997. 0.197, 0.097, 0.097, 0.097, 0.097, and 0.097. So I got, the 1, 2, 3, 4, 5. Then the last one is negative 2.979. Let's go and add all this in the calculator. Okay. I'll give us 0.997 plus 0.497 plus 0.097 plus 0.097 plus 0.097, 0.097, 1, 2, 3, 4. Okay, plus 0.097. Now, for the last one, which is negative, plus negative 3. Okay. What did I miss? I think 0.97, 0.97. Okay. Let me see what I missed. 497. Okay, 497. 0.097. 0.097. Oh, 0.97 right here. So what did I miss? I must have missed something somewhere. 0.97. Okay. 497. 0.97. 0.97. 0.97. 0.97. Okay, 1, 2. Maybe I went too far a little bit. 1, 2, all the way to the end. 1, maybe I put more extra. Plus 0.097. Yeah, there must be some mistakes. I'm trying to figure out where I got 99. Okay, let me look at our calculation again. Oh, 99 it's 993. So okay. 997, 497, 97. 1, 2, 3, 4, 5. Okay, let me start all over. See what is going on. Okay. 0.997 plus 0.497 plus 0.097 plus 0.097 plus 0.097. Oh, 1, 2, 3 plus 0.097 plus 0.097 plus 0.1 plus next will be negative 2.979. Okay, that's it. Got it. It's negative 1. When Adam will get negative 1. I was negative 1. Negative 1 point. So so that the sum of x times px becomes equals to negative $1, which is a loss. So unless you win the jackpot, as you can see from this calculation, and this is for lottery in general, unless you win the jackpot, if you're just winning other amount over the years you are playing the lottery, if you check how much you won and how much money you spent and lost, you will discover that actually you're not gaining. Okay, you're just losing money. Yeah, over time. You know. Does anybody have a question on this? Any question? Okay. All right, let's see. Since there's no question, we'll then move on to the application to business. Look at this. It says a ski resort located in Cleveland loses $70,000 per person when it does not snow very much and makes $250,000 profit when it does snow. Okay. Now, so it loses $70,000 per season when it does not snow very much and makes $250,000 profit when it does snow lots. Now, according to the weather forecast, yeah, this is it. So according to the weather forecast, the probability that it will snow at least 75 inches, which would be a good snow, maybe 40%. Find the expectation for profit. Now let us start. Let's profit X be the profit. That's the gain. So now, according to this question, the company will gain $250,000. Okay, let PX be the probability that it will snow at least 5 inches. 7 inches is a lot. Yeah, that's a lot of snow. So PX, the profit they will make if it snows 75 inches will be, according to the question, is 250,000. And the probability will be 40%, which is 0.4. Now, if it does not snow that much, they will lose 70,000. So we're gonna put that at negative 70,000. And the required probability of that is 60%, because if it is 40%, that it will snow at least 75 inches. So if there's a 40% probability or chance, then in other words, the opposite is the 60%, because if it's 40% that it will snow at least 75 inches, the opposite is that it will not snow at least 75 inches, will be 60%. So that's gonna be 0.6. So now we can now, I'm gonna put the total here. So we have S times PS, which means 250,000 times 0.4. So I'm gonna have a calculator. 250,000 times 0.4, give me 100,000. So I'm gonna put 100,000 there. Okay, 100,000. Now, do the sample here. Negative 270,000 times 0.6. Okay. Negative 70,000 times 0.6. Negative 42,000. Negative 42,000. So if you add the two of them, 100,000 plus 40, negative 42,000. 100,000 plus negative 42,000 plus negative 42,000, 58,000. And this is positive. This is a good business. This is positive. 58,000. So that the expected value, which is sum of S times PS, which is right here, sum of S times PS will be positive $58,000. Which means that it's a good deal. Unlike the lottery that will have a negative symbol sign, a negative net gain. See right here, which is a loss. So this one is a profit. So it's a good business. Any question on this? Any question? Okay. All right. So that's how you do the expected value and the calculate the mean, variance, and standard deviation of a probability distribution. So last Tuesday we covered the mean, variance, and standard deviation of that distribution. Now, today we do the expectation. Now, let me use the opportunity to introduce you briefly to the next topic we'll be handling in this class, which will be binomial distribution. Now, we're not going to do any calculation today on it. I'll just introduce you to it so that when we come back on Tuesday, we jump right into the calculation. Now, many probability experiments or many types of probability problems have only two outcomes, or outcomes that can be reduced to two. For example, when you toss a coin, it will fall head or tail, which is two outcomes. In a basketball game, no matter how much each team scores, it's either they win or they lose. Again, two outcomes. When the baby is born, it will be either a male or female. Two outcomes. Blood pressure, no matter whatever it reads, it is either it is normal or not normal. Again, two outcomes. So all these four scenarios describe the examples of the binomial experiment. And what is a binomial experiment then? Simply put, a binomial experiment is a probability experiment that satisfies the following requirement. The first requirement is that each trial can have only two outcomes, or outcome that can be reduced to two outcomes. That's the first requirement. Second one is that there must be a fixed number of trials. Then the third one will be that the outcome of each trial must be independent of each other. So the outcome of one trial will not be affected by the outcome of the other trial. Then the probability of success must remain the same for each trial. Okay. So now look at the let's see, for the dice. Dice have 6 sides. In this case, the probability of success will be 1 out of 6. So any outcome in the dice, one dice have 1 out of 6 chances of showing up when a dice is thrown. Excuse me. Now for coin, it's 1 out of 5. So 1 out of 2 chances. So these are the what you call the probability of success for each outcome. So this leads us to binomial distribution. Now, the outcomes of a probability experiment and the outcome of a binomial experiment and their corresponding probability of those outcomes are what we call the binomial distribution. Okay. Now, in a binomial experiment, the outcome are usually classified as success or failure. Now, look at the notations we use for binomial distribution. P stands for the probability of success. Q stands for the probability of failure, which we normally give as Q equals P. Then N is number of trials, and then of course X is number of success in N trials. So for this, we have that the formula for the calculating the binomial distribution. I mean, the probability of, to calculate the probability of X successes. For example, it's going to be Px equals N combination X times P to the power X times Q to the power N minus X. You can see we came across this thing again. Remember, we did it here. I introduced it towards the end of last chapter. So for N, starting from 0 to 1 to never, to, forever. So, like I said, we're not going to go into details on it today, because that will confuse you especially for the classwork that I want you to do. So I'm going to let you go so that you can go and complete your classwork by tomorrow. So I'm going to put it right now. Any question before I leave you?
No. You're gonna upload the video, right?
Yeah, that's the main thing. I'm letting you go early so you can go and start working on the classwork now. Okay.
Okay, thank you.
You're welcome.
Is it a long video
Video for
the classwork? Because some are longer than others.
I don't really know because I don't check. I just make the video. But what video are you prefer? I'm talking about classwork that is due tomorrow.
Yeah, the classwork, usually you upload a video along with it. But if it's an Excel assignment, but if it's a like Pearson assignment, then it's just like you don't upload a video, which makes sense because they give us like help. Does that make sense? Like for the Excel ones, you upload videos that help us.
The one you have in Pearson. Pearson is the homework, so that one is different. I'm talking about the classwork now. So Excel assignment come with video, but this one doesn't come with video, but you can always check the video I did online by typing my name and typing the topic. Okay. So
Did you get me for attendance?
what's your name, sir?
Michael Udell?
Yes, I got you, man, Mister. You got it.
Okay, thank you.
You're welcome.
Dr.
All right.
Patterson.
Did you get me, Patrick Coloco?
Give me 1 minute. Let me check. What's your name again?
Patrick Coloco.
Patrick. I'm looking for it here. Yeah, I got you, Patrick.
Do you have Christian Mullins?
Christian?
Yeah.
Yeah. Christian Mullen, right? Is it
Yeah.
Mullen or Morris? Mullen, right?
Yeah.
Yeah, I have to have Christian here. All right, guys. I see you on Tuesday.
Did you get my name, Amaya
Did you
Patterson?
get my name?
Well, let's do it one after the other. Say the lady first. Lady, what's your name again?
Amaya Patterson.
Yes, I have yours. Am I right here?
Thank you.
Anthony Paris.
Paris. Yeah, give me 1 minute. I think that's one of the, yeah, I got you.
Thank you.
I emailed you to like a couple days ago. I don't know if you pay attention to your emails, but I did email you.
Okay. Everybody's gone actually, so you can tell me.
It was about 2 assignments that I missed due to me struggling and not having like a HP computer. And I was gonna see if you was gonna let me if I was gonna be able to make it up. And somebody also asked you another question that I emailed you. The assignment that doesn't have no directions to it. What did you say about that?
Which are you talking about the one that is due tomorrow?
Yeah.
I'm gonna put it. I didn't put any question there. I'm gonna put it. That's why I'm letting you guys go early so you can do it. So after this class now, I'm gonna put the questions on that.
Okay, but
the class for the making up assignment, like I said from the very beginning of this semester, is based on your attendance. And they start on 2nd week of April, which is that's when you start making that request. It should be next week. No, not gonna be next week. Yeah, probably.
Okay,
That's only then if you're making the request, you have to check your grade on attendance. Make sure it's up to 70%.
Oh yeah, my grade is higher than the 70% for attendance. I'm always in class, so.
Okay, then next week.
Okay, thank you.
Thursday, that's when we'll start. Like I'll start accepting the request for makeup.
Okay, that was all.
All right.
Thank you.
You're welcome. Goodbye.